Hi, in this video we're going to continue looking at the mathematical operations using decimals. So as usual, I import the decimal and the decimal module and the decimal object of the decimal class. And the first thing that we want to look at are going to be the div, which is this, and the mod operators, okay? And that's because they are fundamentally different between integers and decimals, or floats and decimals. And that's because of the way that the div operator works. This integer division works differently for the decimals than it does for integers. So let's take a look at that. And in particular, I want to point out that it always does satisfy this equation here, which you're probably tired of seeing by now. But it does satisfy this equation here, okay, where n and d are the numerator and denominator, okay, and when we think of this as a fraction. All right, so let's take a look. Let's start with some integers, x and y, let's say 10 and 3, and we can print x div y and x mod y, or we could just print div mod x comma y, right? That would work the same way. We can also do this, div mod x comma y, which just returns a tuple of the div and mod operators respectively. So if we do that, we'll notice that we have, 10 div 3 is 3 and 10 mod 3 is 1. And of course, the div mod returns the same thing. And the other thing too is that we're going to go ahead and check and make sure that x equals y times x div y plus x mod y, right? We know that we should be satisfying that equation, and we do indeed. And we've seen that before when we were looking at integers. Now let's go ahead and do the same thing, but instead of using integers, we're going to use decimals. So I'm just going to copy paste this entire chunk of code, and instead of doing this, we're going to do decimal 10 and decimal 3. Now, as we discussed, these are both positive numbers. The result is going to be positive, and therefore the computation is going to be identical. We're going to get the same results, right? So we also get 3, 1, right? And we get 3 decimal 1, and we get that this equation is true, okay? And that's because we're dealing with positive numbers. Now, let's change this, and let's make x negative here, and let's make x negative here. And let's rerun this, and you can see now that our div is negative 4 and our mod is 2. If we rerun it here, you'll see that our div is negative 3 and our mod is negative 1. So we have different values for the div and mod, but the equation still holds true in both cases, right? So just be a little careful with that, because there is a difference, as we looked at in the previous video, on how this div is calculated. And therefore, in order for this equation to still be satisfied, that means that the mod has to be calculated slightly differently too. Okay, now in terms of other mathematical functions, so other math functions, if I can spell, or type I should say. So let's look at some other math functions. Now the decimal class has a lot of math functions built in. So if you want, you can do, you can just go online and look at it, or if you want here, you can take a look. Don't worry about the dunder methods for now. We'll look at those kinds of methods when we get into object-oriented programming. These are special methods that are used to actually implement certain functions in Python. And remember, Python is very polymorphic. So when you do this div operator or this mod operator here, well, it works differently here and here based on the context, because these are integers, these are decimals, and it knows that it's going to calculate things differently, and it knows that because the decimal class implements those two operators. And so by polymorphism, it knows that, okay, if I'm running this calculation here, I've got 2 decimals, I've got to go and use the implementation of div in the decimal class, not the implementation of div that we have somewhere else, let's say if we had 2 integers, right? And that's what these dunder methods are for, but we'll see that in a lot of detail later on in this course. So let's go ahead and skip past those and see some of the functions that we have. And there's quite a few. You got the copy sign function that we've seen before, but here you have the exponent, right? That's the exponential function, so e to the power of x, right? And there's other things as well, but we have like, let's skip ahead. Here we have the natural log, here we have the log base 10, here we have a log to any base b, and so on. It's got max, min. I mean, there's a lot of stuff that it can do. One thing that it doesn't have, for example, are the trigonometric functions. But it has things like the square root, which would have to scroll down to see more. Here's the square root, for example. So all these methods are implemented in the decimal class. So let's take a look at how we have to deal with this. Well, first of all, let's see how we would call it, right? Because how do we call these methods? So let's say we have a, which is decimal 1.5. Now we can print a. Now we want to find, let's say, the natural log of a. Well, we'd have to say a dot ln. So it is basically a class method that you call on the object, right? It's not, you don't say ln of a like you would when you were using the math module, for example, right? We do it this way. You can print some of the other ones too. We can say, you know, take e to the power of 1.5, or you can print a dot square root, let's say if you wanted the square root, and so on, right? And so we get these values here. Now, what's interesting is that these are going to be a little different than if we were using floats. And again, this is because we will have a different real value for 1.5 depending on whether we're using a float or using a decimal. So you can certainly import the math module, okay? So we can import math and we can run the math functions on a decimal. So we can say, for example, math dot square root of a. We can do that. But as you can see, it's not quite the same, right? And in this case, we have 1.5, so we're actually getting the same digits. But let's change this to 2, let's say. Well, actually, let's change this to 0.1. Let's do that. And as you can see, now we're starting to get some little differences here, right? So this is 7933 and this was 794. So that's not rounded, right? That's because there is a difference in the representation. And we'll see that in more clearly in a couple of minutes. So you can call the math functions on a decimal. But what happens is that it first converts the decimal to a float and then runs the operation. And that's probably not what you want. In general, you want to try and use that fixed precision that you have with decimals and that exact representation that you have with decimals that you don't have with floats. So therefore, you probably want to stay away from that. So let's see some differences. So I'm going to define two variables. One will be 2 as just a regular integer, and the other one will be a decimal integer. And what we want to do here is I want to look at the root of float. And we'll do that. And then we're going to do a root mixed. Now, root mixed, what I mean by that is I'm going to take the square root function from the math module, but I'm going to apply it to the decimal version of that integer. Okay? And then we're going to take the root purely in the decimal, which is done by saying x dec dot square root. Okay. And now we're going to print and we're going to format each one of those so we can get a better idea of what's going on. So let's format it this way. So let's do the root mixed as well. And then we're just going to print root dec. I don't have to format that one. And let's see what we get. So as you can see, the first two values are identical. Even though we passed in the decimal equivalent of 2 to this method, right? The square root method is in the math module. It first converted it to a float. So this 2 was first converted to a float, and then it performed its float version of the square root, which is not the same as what we get when we performed the square root on the decimal number. And one thing that we can look at that's interesting is to look at this. So now I'm going to take this, copy paste, and I'm going to take root float times root float, right? That should give us the original number back. Now, the problem is that, sorry, root mixed. The problem is that square root of 2 is not a rational number. So, in fact, we'll probably won't get our original number back in any of those cases, right? Because square root of 2 is 1.414 and then a bunch of decimals, and it goes in, it goes on infinitely. Of course, we can't store an infinite number of digits on the computer, so we're not going to end up with things back exactly the way they were if we multiply the two square roots. We're not going to get 2 back precisely. But let's see the difference. As you can see, this is what we get back when we use the float operation, right? So we're off at this digit here, right? 2.004, and here we start being off. But if you look at the precision of this, if you look at how, this number is compared to 2, it is much closer to 2 than this number here, right? And than either of those numbers there. So again, we had a better, if you want to think of it that way, square root. Now, we can make this far more obvious if we change this to 0.01. So let's go ahead and change that to 0.01. Now I want to point out that if we were to do a format of x at, let's say, 27, I got to run this first, I guess. There we go. Right? We don't have exactly 0.1. So already we have an issue here with x. It's not exactly 0.01. Now, what's the square root of 0.01? Well, it's 0.1. So let's go ahead and run this again. So this is the same code. And let's see what happens. Remember this thing I said about not using floats? Well, I made that mistake there. Because before I was using integers, it didn't matter. In this case, I'm using floats. I got to be careful. So I probably should have also printed out x decimal to make sure I had that right. Okay, so there we go. So the x decimal is exactly 0.01. Before, when I had this, it wasn't, right? It was actually this number here because I was pushing a float into the constructor. So I didn't get exactly 0.01. So that's an easy mistake to make. Be careful with it. All right, let's run our calculations, and now let's run it again. There we go. So now root decimal is exactly 0.1, whereas the float version and the mixed version gave us this approximation to 0.1. And so what happens when we now multiply the results with each other, then you can see that in the case of the floats and the mixed, we don't get 0.01 back exactly, whereas in the decimal case, we did. We got 0.01 back exactly. All right, so that's it for the math operations. So just to recap, you can use the math library, and there are functions in the math library that are not available in the decimal class. So there, you don't have much of a choice. You're going to have to basically work with floats, right? But the decimal class does implement a fairly large number of mathematical functions. All right, thanks for watching, and I'll see you in the next video.